All right, Common Unit Assessment 5, Retake. This counts as retake and corrections. Wait, corrections first and retake, whatever. It counts as both. All right, if the roots of a quadratic equation are negative 5 and 7, then the equation can be written as x plus 5 times x minus 7 equals 0. The reason why that works is because if you set both of those factors equal to 0, hold on, let me slow it down for you, honey. Oh, all right, so we solve for x, we get x equals negative 5. And then over here, set that one equal to 0. If we add 7 to both sides, we get x equals 7. And those are the numbers that we started with. All right, don't forget roots are synonymous with zeros, solutions, and x-intercepts. Those all mean the same thing. Go ahead and try number 2 on your own right now. Number 3. If the equation of a parabola is given as such, what is its negative root? So we're going to solve this because, again, root is the same thing as solution, is the same thing as 0, is the same thing as x-intercept. All of these things mean the same thing. So let's set this thing equal to 0. All right, so you could do this right here. You could use the t-chart method. All right, multiply those two, use the t-chart method, and see what two factors are going to add up to 0. We're not going to do that, though, because time is money. Nah, but for real, we're gonna use the difference of squares instead. So I'm gonna take that away, scoot that over. All right, so difference of squares. Okay, this is in your notes for solving quadratic equations. All right, I'm gonna take the square root of this 81, which is 9, and the square root of x squared is just x. I'm gonna take the square root of this 49, which is 7. Boom. All right, so that's where I'm gonna put those twice. And then we're going to put a plus here and a minus here. The reason why this works is, well, I'm not the reason, but we know that this works because if you multiply that, you get 81x squared. If you multiply that, you get, brain fart, my bad, 63x. If you multiply that, you get plus 63x. And if you multiply that, you get 49. Negative, my bad. Negative 49. These are going to zero out, so you end up with 81x squared minus 49. Okay, so you still end up with the same thing. That's the magic of difference of squares. So, yeah. All right, so once we get to that step, you thought it was over. That's cute. Once we get to that step, we're going to then make each of these factors equal 0, just like we did on number 1. And then we're going to solve for x. So I'm going to subtract 7 on both sides. And that gives me 9x equals 7. And then I'm going to divide. Oh, minus. I was like, wait, where'd it go? Then I'm going to divide both sides by 9. And that gives me x equals negative 7 over 9. And then I'm going to do the same thing for this factor. So that's 9x minus 7 equals 0. If I add 7 to both sides, that's going to give me 9x equals 7. If I divide both sides by 9, that gives me x equals positive 7 ninths. This is asking for the negative root. So there you go. Go ahead and try number 4 on your own. Sorry for the sniffles. It's that time of year. Number 5. All right, we got choices, you know what I'm saying? So this is what I'm going to choose to do. I'm going to take away 10 from both sides. We got to solve this. You could use the quadratic formula if you want to. I'm not, but you could. All right, so that's going to be 2x squared. That's going to zero out equals 200. And I'm doing this because I see that this doesn't have the b term. And so it doesn't have like the x term, the term that just has the x. So when that happens, I would say use square root method like I'm doing right here. All right, and then we end up with that. And then if I take the square root of both sides like that, I end up with x equals plus or minus the square root of 100, which means x equals 10 and x equals negative 10. because the square root of 100 is 10. Get it? All right, go ahead and try this one. Number 7, we're going to simplify this 150. I taught y'all how to do this on your calculator. I think it was menu. Is it 2, 3? That sounds right. Let's go check. I'm not sure. All right, so menu number, yeah, factor. There you go. What was it? I hope it was 150. So 2 times 3 times 5 squared. So that would be 2 times 3 times 5 squared. And then we got a set of doubles right here. So we're going to take that out. Everything else is going to stay where it is. When you take it out, don't forget it becomes a single. The reason it becomes a single is because the square root of 25. Sorry, let me slow it down. Let me slow it down. Okay, so I'm just showing you why it becomes a single, okay? So 5 times 5, right? That's 25, right? The square root of 25 is what? 5. So you see how that double 5 became a single 5? Yeah, that's that. All right, so I'm going to simplify this to 5 square root of 6. Boom, done. I got that 6 because I multiplied the 2 times the 3, okay? And then the 5 just came down. Go ahead and try this one. Number 9, we got this equation right here. Uh, and then when Jada solved it, she got x equals 5. Is she correct? And explain. So let's go ahead and solve this. So right off the bat, I see that 27 is divisible by 3 and 3 is being multiplied by the set of parentheses. So I'm just going to go ahead and do that. And then we end up with 9. Ooh, and that's beautiful. That's beautiful because if I take the square root of this, I get x minus 2. If I take the square root of this, I get 3. And then from here, I can just add, oh, my bad, I'm sorry. Positive or negative 3, right? So from here, if we add 2, I'm gonna go ahead and split this up. So x minus 2 equals 3, x minus 2 equals negative 3. I just split it up. You can split it up now or later. And so if I add 2 to both sides, I get 5. If I add 2 to both sides, I get negative 1. So Jada is partially correct, but she's not fully correct. All right, go ahead and try number 10. Number 11. The graph of g of x is shown. Which value best represents the zero of the function? Respectfully, if you got this wrong, actually, no, you know what? I'm gonna be nice. If you got this wrong, that's just because you don't listen. Zero. It also means x-intercept. Remember, I said that for number 1 and number 3, I think. Anyway, so there it goes. That's it. That's the x-intercept. That's it. Don't make it complicated. All right, number 12, go ahead and try it. 13, let's go ahead and solve this equation. So as I am looking, this might be factorable, but I'm not going to try it. These numbers are kind of janky looking and I can't figure. Oh. So I'm going to use the quadratic formula to solve this. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so I'm going to substitute the values in the next step. All right, so don't forget this is A, this is B, and this is C. So negative 17 becomes positive 17 plus or minus the square root of negative 17 squared minus 4 times A, which was 6, times C, which is 12. All that's going to go over 2 times 6. All right. If you are in on level algebra 2, at this point, you could use a calculator to do plus and hit enter, and then minus and hit enter. If you are in honors, then we gonna work this like we supposed to. So that'll be 17 plus or minus the square root of 1 over 2 times 6, which is 12. All right, so that's 17 plus or minus 1 over 12. So I'm going to go ahead and separate this. 17 plus 1 over 12, which equals 18 over 12, which equals 3 over 2. And then we got 17 minus 1 over 12, which equals 16 over 12. And what's that? 4 over 3. All right, so if you are using the decimal form, then you should get x equals 1.5 and x equals 1.3 repeating. And then if you're using the fraction form, then there you go. Go ahead and try number 14. Solve the quadratic equation for x. All right, same thing. Looks like it. Actually, no. I think we could factor this one. I'm going to try to see if we can factor it. So I'm going to do 2 times 3, which is 6. Make my little table. 1 times 6. 2 times 3. Also, this is negative, so because it was a negative 3. So we could do that. And then, well, do 3 times negative 2, 6 times negative 1. Okay, great. So from this list, are there any two numbers that will add up to that? And yes, those will. So we're going to take that 1, put it over A, and then that will be 2x plus 1. And then we'll take that negative 6, put it over A, simplify it. And I'll simplify it to the right. That'll be negative 3 over 1. And that will be 1x minus 3. All right, so I'll put that over here, make that equal 0. All right, so once you got that, we can just separate. So 2x plus 1 equals 0. 2x equals negative 1. If we subtract 1 from both sides, divide both sides by 2, we get negative 1/2. Over here, x minus 3 equals 0. Add 3 to both sides, we get x equals 3. Now, you can use the quadratic formula like we did on number 13 as well. Either way, go forth and be great. You should get the same answers either way. So for number 16, you can do the quadratic formula, or you can try to see if you can factor. Number 17, Johnny was trying to solve the problem. Where did he make his mistake? Or did he make a mistake, and if so, where? Okay, so let's see. This is our equation. A is 1, B is 5, C is 6. He's using the quadratic formula to solve. And right away, I see in step 1, He did not use the correct value for A. I guess he assumed since X did not have a number in front of it that it was 0, but that was supposed to be a number 18. Go ahead and give it a shot. Number 19. We're going to write a quadratic equation that has these two roots, but we want this one in standard form. On the test, the answer choices were in standard form. So that's going to be x plus 4 times x minus 1. This is just like problem number 1. So we're going to distribute, get x squared, and x times -1 is negative x. 4 times x is 4x. 4 times -1 is -4. Let's go ahead and combine these two like terms. And there you go. Go ahead and try 20.